Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 3637 Trionic array 1. You are given an integer array nums of length n. An array is trionic if it exists indices 0 less than p less than q less than n minus 1 such that 0 to p is strictly increasing and p to q is strictly decreasing and q to n minus 1 is strictly increasing. Okay, if you see p and q, p is strictly greater than 0 and q is strictly greater than p. Okay, and yeah, if all these conditions holds true for a given array, that means it is a trionic, then we have to return true or else we have to return false. Okay, let's look at some examples. Okay, let's take nums as 1 3 5 4 2 6. Okay, so if you see 1 is less than 3, 3 is less than 5, it is strictly increasing. 5 is 4 is strictly less than 5, 2 is strictly less than 4, so this is strictly decreasing, and 2 is less than 6, this is strictly increasing. Okay, if you look at this input 2 1 3, there does not exist a p such that from 0 to p it is strictly decreasing. If you see 0, this is the 0th index. Okay, 0 index and p both are actually overlapping here. Okay, so ideally there should be one more index, one more point which is strictly less than this, but this point does not exist. Okay, as a result 0 and p are overlapping here. So whenever there is only one point, okay, which is not strictly increasing or not strictly decreasing, that means this is not a valid trionic at all. Okay, there has to be at least in a given subpart, there has to be at least two elements in it. Okay, so idea is to identify till what index it is strictly increasing and till what index it is strictly decreasing. If the, let's say I have a function which take a current index and it will identify till what index it is strictly decreasing. Okay, if the current index and the index till which it is strictly increasing, if both are overlapping, that means it is not a trionic. Okay, so if you see here, the index till which it is strictly increasing and the index is current index both are overlapping, as a result it is not a trionic. Okay, so let's have a function called get index, which will take an index and which will also take a flag whether to check for strictly increasing subarray or to check a strictly decreasing subarray. Okay, if flag is true, that means I will check for strictly increasing. Okay, if flag is true, then nums of I minus 1 is strictly less than nums of I. Okay, I will go as long as this condition holds true. Okay, so what I will do for a given start, okay, for a given input, I will start from its next index and go as long as this current index, okay, I'm talking about strictly increasing, right? So let's say I'm starting at this particular index. Let's say my start is this. Okay, now I will check how many such elements exist from this index, just an index beside start, such that all the elements is greater than its previous element. Okay, so I is starting from start plus 1 and I will go all the way till the end, and as long as my previous element is less than the current element, I will keep on continue. Okay, the moment it breaks this condition, okay, the moment it breaks this condition, that means I have encountered this index. Okay, when my I is over here, okay, if you see this is not less than this, okay, that means just it is strictly increasing till the index I minus 1. Okay, if my I is over here and if the first condition breaks, okay, if you see nums of I minus 1 is not less than nums of I, that means it is strictly increasing till I minus 1 index. Okay, so I will be returning I minus 1 in the else part. Okay, now let's say I was looking for the strictly decreasing part. Okay, so then I will start from, let's say I have given I as this and I want to identify till what index it is strictly decreasing. Okay, so I will check from the next element as till the n as long as my nums of I minus 1 is strictly greater than nums of I. If as long as this condition holds true, I will increment my I. The moment this condition does not hold true, that means it is strictly decreasing till I minus 1 index. Okay, let's say it has all the elements are strictly decreasing, and let's say we have reached the end element. Okay, that means I will be reaching n, so that my answer should be n minus 1. Okay, so that is what in the other case I have written n minus 1. Okay, so what I will do is I will keep a boolean flag called true, which will tell me if flag is true, that means I was looking for a strictly increasing sequence. If flag is false, that means I am looking for strictly decreasing sequence. Okay, in the problem statement it was initially mentioned that we are looking for strictly increasing sequence. Okay, so if you see this graph, it has been moved from strictly increasing to strictly decreasing. That means there is a one flip over here, and from strictly decreasing to strictly increasing, that means there is one more flip over here. Okay, so if my given array contains satisfies these properties, that means there should be two flips, right? If the given array contains more than two flips or less than two flips, that means it is not a trionic. Okay, so that is what I was checking for, the number of flips it goes through while I was traversing through array. Okay, so first I have instantiated I equal to 0, and as long as my I is less than n, I will check for a given I till what point it is either strictly increasing or strictly decreasing. So initially it is, I will be checking for strictly increasing one, so I will get an index till what point it is strictly increasing. Okay, so if the current index, okay, if the current index and if the index till which it is strictly increasing, if both are same, that means it is not a trionic. Okay, so this is the use case. Okay, so I was looking for a subarray till which it is strictly increasing. Okay, since there are no such elements, okay, my function will again return the same input. Okay, so in this case I will be returning false, or if the number of flips are greater than 2, even in this case also I have to return false. Okay, if this condition is not holding true, that means I have reached this point. Okay, now I have to update my I over here. Previously my I was here, now I have to check given this I till what index it is strictly decreasing. So I have updated my I with index, and I have changed my flag to the negation of it. So previously if I was looking for strictly increasing, now next time I have to look for strictly decreasing, and I will include this as one flip. So I will come back and I will check for the index till which it was strictly decreasing. Now again I will check whether it is overlapping, I mean the current index and the index till which it is strictly decreasing. If both are same, then I have to return false, or else I will update my I pointer and again I will flip it. Okay, there will be a point where we will be actually getting the n minus 1, that means we have reached till the end. Okay, if you take this as I, and if you ask to get the index till which it is strictly increasing, then we will get index as n minus 1. So the moment we reach n minus 1, that means there are no more elements to actually validate. Then I have to check the total number of flips I have done so far. If the total number of flips is 2 the moment we have reached the last index, that means it's a trionic, or else it is not a trionic. Okay, so again I have kept true over here, doesn't matter whether it's true or false, because we will be returning from either one of these itself. Okay, so let's try to submit this. As you can see, all the test cases were passed and it is pretty efficient solution. So before jumping dive into time complexity analysis, I highly recommend you to subscribe to my channel if you are liking the content which I am posting, and hit the like button and also the subscribe button. So let's jump into time complexity analysis. As you can see, we are not using any extra space, so there is no the space complexity order of 1. Now the time complexity is, we are just iterating from I till all the way till the end. Okay, so every element we are just processing one time. Okay, we are starting at this index and we are going all the way till the end, so every element we are encountering only once. Okay, so the total time complexity will be big O of n, where n is the length of the input array. Okay, so the time complexity will be big O of n and the space complexity will be order of 1. Okay, so I will be posting this the solution in the comment section or in the description section. You feel free to check it out, and Don't miss to subscribe to my channel and hit the like button and share your valuable feedback in the comment section. Thank you.